You know Jiminy Cricket? That's right, Pinocchio. It's the little guy that tells him to do the right thing, right? So, we're starting number 6 here. Just a recap, we factored the denominator. We then said the domain. Before I cross out, x cannot be 0 and x cannot be 1. We removed x subtract 1. The 0 that comes from x subtract 1 is positive 1. I plugged it back into the reduced form, and the y value of the whole is 1. What's the next step that we're going to do? Are the x-intercepts. What's left in the numerator? Is there any 0 from that numerator? Is there any way to make the numerator 0? And there isn't, because it will always be what number? And never be 0. So what that mean? There is no x-intercepts. Y-intercept. So what number do I plug in to find the y-intercept? So when I plug in 0, what do I see? So when I plug in 0, I end up with 1 divided by 0. What does that mean on my graph? There is no y-intercept. It makes sense, because why is there no y-intercept? Well, that's because what's left over in the denominator, x squared, what's the 0 of that? And the answer is, so when I look at my domain restriction, x cannot be 0, so what does it create? A vertical asymptote. X cannot be 1, what does it create? A hole. So a domain restriction is either going to create a vertical asymptote or a hole. So when I go back, I make sure I understand each one, right? What remains creates a vertical asymptote. What you're removing creates a hole. So why is there no y-intercept? Because over the y-axis is an asymptote. There's no point on the y-axis because there's an asymptote there. All right. How do I find the horizontal asymptote? What's the power on top? And what's the power term on the bottom? Is there one more powerful? And because the bottom is more powerful, the horizontal asymptote is y equals 0. All right, we're ready to graph now. Remember the ones that like color? So I'm going to do one picture in black and another one in red if it's undefined. Now, we might have to find more points on our graph because we only have, right now we only have a hole. So right now, I know at x equals 0, what do we have at x equals 0? And what else do we have? At y equals 0. Yes? And we have a hole at 1 and 1. Now, an undefined point can still act like a point for my curve. It's just an undefined point. So let's see what we already know. So from the hole, do I know already the end behavior? Where's it going to the right and left? So the end behavior is the horizontal asymptote. So I already know the right end is going to follow the horizontal asymptote. The right end, it's getting closer to 0. What's going to happen? The other side of the hole, what direction does it go? What's the behavior at the vertical asymptote? It's either going to go up forever or it's going to go down forever. So what's going to happen in this case? Good. So it's above the horizontal, right? It's going to go up forever. Now, something I didn't write down. Vertical asymptotes have multiplicity 2. Look at the denominator. What's the exponent where I got 0 from? That means the multiplicity is what? Even. Now, for a vertical asymptote, we're not talking about does it touch or cross over. Instead, what we're talking about is do both sides go up or down, or does one go up and one go down? Like, do they go together, or do they go in opposite directions? Okay? When it's even, they go together. So if you know one side, then you know the other side. If it was odd, one would go up and one would go down. So in other words, in this case, because it's even, guess what's going to happen to the other side? Notice that's different, right? If it was odd, then the other side would have to go in what direction? Down. So because it's even, both ends go up. If this end was down, then both ends could also go down if it was even. But they're not going in opposite directions. That will give me a good indicator for our next point. I need a point here. What's the easiest x value to get a point to curve through? -1. So if I go 1 divided by -1 squared, what answer do I get if I plug in -1? So -1 squared is +1. Can you see how we confirmed that both sides are what? Both sides are above, right? The x-axis. So, do we already know the behavior at the asymptote? Yes? It's going up. What's the left end behavior? Where's the left end going? All right. I want you to notice for the range is greater than what? So for the range, I'm just going to write down that y is greater than what number? What else can y not be? Now, this is an intriguing one. I want you to notice that we would have put down the y value of the whole, which is what? But look on the other side. Isn't y 1 on the other side? So can y be +1? Yes, when it's what? Negative. But can it be +1 for that? So in other words, does y equals 1, does it exist on my graph? Yes. So the only value y can't be, it's 0 and less. Let's do this on our calculator. So, what I want us to do is type in the question. I don't want to type in after we removed a variable or a factor. Now, for this calculator, in order to do a rational function, I need to start with parentheses. Can you start with the parentheses? And then type in x subtract 1 and then close it. What the parentheses does is it keeps all of it in the numerator, and then the fraction line is dividing. So press the divide button, and again, I need parentheses. The numerator needs parentheses, and the denominator needs parentheses. And then if you type it in correctly, do you have a glare right there? It feels like the glare is not where I'm typing when I look on my computer screen. Do you see the bottom bar? I know, it's tough, right? I don't know how to solve this. All right, let's try it again. How about that? Can you see that? Let me turn off all the lights then, so that you can see it that way. When you watch the video, I think you'll be able to see it. It just might be in terms of the LCD. All right. Did you type in x cubed subtract x squared? Yeah. So I went diamond F1. So to type in an equation, you press diamond F1, press enter, and then you type it in the bar on the bottom, you type in the equation. So when you press enter, what does it actually look like because you use parentheses? Can you see x subtract 1 over x cubed subtract x squared? So I'll say it again. The numerator needs parentheses. The denominator needs parentheses. Yes, that means that the divide sign is the fraction line. Next, are you ready for next? So, next we're going to change the window. So diamond F2. Can we press diamond F2? Now, for our window, there is no direct right answer to this, but when I look at our graph, the important points are 1 and -1. So I'm going to create a window close to 1 and -1. So in this situation, I'm okay with the x minimum being -5, and we can make it symmetric. The x max +5. The scale can stay 1. And we're going to do the same thing for the y minimum. So -5 and +5. That way it will look symmetric when we graph it. So can you change your window? Then press diamond F3. What happened here? Let me see this again. Oh, what mistake did I make? I made a mistake. Not that, right. This should be -5, and this should be... What the heck? My calculator is so slow right now. All right. I know. I see it. I was like looking off the computer screen, and not the computer is like delayed. All right. I feel better now. Okay. All right. So here, first of all, do you see your graph there that we just created? Now, do you see asymptotes on this graph? No, you're not. It's going to be empty, right? Here's another good question. Do you see? Listen. Do you see where the hole is? On the graph. But can I tell you where you would see the hole? Do you see in yellow where it says table? Yeah. In yellow, do you see where it says table? Yeah. Press diamond F5. And when you go diamond F5, what do you notice when x is 1? And x is 0. So at 0, it's undefined because it's an asymptote, but at 1 it's undefined because it's a hole. So when you look at a table, you can see the right, but off the graph, are you ever going to see a little donut like the way we draw it? So don't expect you'll be able to see the hole when you do a graphing calculator, but when you do a table, then you'll be able to see it. Hey, good morning. All right, question number 7. Thank you. He's here. Michael, this is for you at the end of the period. So, number 7. I need you to see how many steps can you do without me? So, number 7, step 1, of course, is to factor. So, if we can't factor, we're not going to be able to analyze this. Step 2 is, tell me the domain restrictions. And from the domain restrictions, it will either be a vertical asymptote or a hole. And we're just going to go one step at a time and practice together. You are going to learn when you do your homework and figure out like the hard work of going through what you don't understand. Then we're going to have a quiz. So, for number 7, did you recognize the numerator is a difference of squares? So one's 2x plus 3, and the other is 2x subtract 3. When I look at the denominator, they have 2 in common, and then what's left over is still a difference of squares. So that's x plus 1 and x minus 1. All right, do the next step. Tell me the domain restrictions. So when I look at the denominator, there are two numbers that x cannot be. Positive 1 and negative 1. Are there any factors that are removable? So again, are there any factors that are removable? That means there are no holes. That means both in the denominator create vertical asymptotes. I'll do that right now. What are the two vertical asymptotes? X equals 1 and x equals negative 1. So when you have something that's undefined, it's going to create a vertical asymptote or a hole. Why is there no hole? Because there are no factors that are removable. So what remains are vertical asymptotes. All right, continue. How do I find the X-Intercepts? Where do I look? In the numerator or denominator? So, can you take a factor and tell me it's 0? So the first factor, what would you do to tell me the 0? You would subtract 3 and divide by 2. So when you subtract 3 and divide by 2, on the graph, where would you go to? 1.5. And what's the other one? You would add 3 and divide by 2, and again, on the graph would be positive 1.5. So where are your X-intercepts? Negative 1.5 and positive 1.5. What's the multiplicity on both? They're both odd, aren't they? That means that both they are going to cross. How do I find the Y-intercept? Is I plug in 0 for x. Now, usually, to find the Y-intercept, not the factored form, but at the beginning, put 0 in for x. It's easier. So if I plug 0 in for x, I'm left with negative 9. Plug 0 in for x, and I'm left with negative 2. So I know a negative divided by a negative is positive. What's 9 divided by 2? Exactly 4.5. We have no holes, so I'm just going to cross that out. Horizontal asymptote. You ready? Again, don't go to the factored form, okay? Go back to the question that's expanded. How do I find the horizontal asymptote? It's power term over power term. What's the power term of the numerator? 4x squared. What's the power term of the numerator? 4x squared. What's the power term of the denominator? 2x squared. I want you to notice that the variables match, right? They both have a degree of 2. So when I divide, what I'm left with is y equals 2. All right, we're ready to graph now. So I want you to put on your graph the X-intercepts and the Y-intercept. I want you to put the asymptotes on your graph. Then we're going to understand end behavior and the behavior at each vertical asymptote. So we first analyzed to find intercepts and asymptotes, and we put it on our graph. I need to make sure we're here together. Some of you feel intimidated by knowing how to graph what's next, right? So I want you to understand the end behavior. What gives you the end behavior of this function? So where's the right end going? To the what? The horizontal asymptote. Where's the left end going? Can you see how I start there? I take the point that I have, and I first start with the end behavior. Then I'm going to look at what happens at vertical asymptotes. So when a graph goes to a vertical asymptote, it will either go up forever or down forever. So on the left, follow the direction. It's under the horizontal. What direction is this curve going? Up forever or down forever? So we're going to go to negative infinity. Then, what did I put down beside the vertical asymptotes? That means the exponent is an odd number, yes? That means on one side it goes down forever. On the other side it must go up forever. So on one side it goes down, and on the other side it goes up. Now, do you see a point to connect it to? The Y-intercept?
Yes.
Now, again, when it hits the vertical asymptote, it's either going to go up forever or down forever. Now, it's not going to go down from here because we only have how many X-intercepts? If it went down forever, it would create another X-intercept that doesn't exist. So what's the only direction it could go from here? Can it go down and create another X-intercept? Or what is it going to do? So it either is going to go to infinity or negative infinity. Why can't it go down? Is it can't create another X-intercept. You could also plug a fraction in, but I don't think you want to do that, right? Do you want to plug in 1/2 and see? So it can't create another X-intercept. There's only two of them. So the only direction is what? Up. So what does that mean for the other side? If it's odd again, what must this side be? And then can you connect with the point that we have? And you've just drawn the rational function. We're going to do this on our calculator again. Thank goodness I videoed this so that if you need to do the question over again, you could with a piece of graph paper to learn it. So I'm going to type this in. We are done with this. The range here is actually quite challenging because I don't know for sure if this is really the turning point or it might even go lower. So I'm going to ignore the range right now. Because mathematically I need calculus to know where that turning point is, to know for sure where it is. So maybe off the graph I can see better. So can you press diamond F1 again? So press diamond F1. Now, you already had this from the last question, so clear it. Press enter, and then start with the parentheses. We're going to type in 4x squared subtract 9. Close the parentheses. The divide sign is the fraction. Open up another parentheses. 2x squared subtract 2. And close it. If you type it incorrectly, can you see the picture matches what it should? Because you use parentheses. Now I'm going to keep the same window. I don't think I need to change the window. So just press diamond F3. Now, do you notice that that is 4.5 up there? So I'm actually going to change the window just a little bit. So it matches what's on your page. So on your page is a 10 by 10. So I'm just going to match what it would look like on your page. So negative 10, positive 10, negative 10, positive 10. That's what you have on your page. Now, for some reason, I can't explain it to you completely, that on the 89, what does it look like it's trying to graph? It looks like it's trying to graph asymptotes, right? Some people might not even see that when they type it in. These are not asymptotes. The calculator is trying to calculate something undefined. It is creating these weird vertical parts here that look like that's where the asymptotes are. But more importantly, ignore this vertical part here. Right? So, do you see the part that's in the middle? And do you see the part on the sides and see how they match, right? For some reason, does everyone have these when they do it?
No.
I don't know why. The Inspire wouldn't do that. So there's some setting that's making it look like there's an asymptote there when there's not. But do you see the curves, right? And know where it's at. So I need to know. Now the easiest way to graph it for you is through Desmos. But for your AP exam in stats, for your AP exam in calculus, you don't get Desmos. So it's important that we are comfortable with a graphing calculator, and we can also use Desmos too. So maybe for the next one I'll use Desmos, or maybe I'll keep practicing with this. All right, number 8. All right, number 8. We're getting to a point where you're going to have to be independent. You're getting to the point where I'm going to make people go up to the board and show me if they can do something or not, and they're not just going through the motion. So, number 8. Step number 1 is to factor. So can you put the effort into factoring? To factor this, we're going to go 3 times 8 is 24, and negative 14. The two numbers that multiply to 24 and add to negative 14 are negative 2 and negative 12. So I'm going to substitute in. I'm going to substitute out the negative 14 and put in negative 2 and negative 12. And then I'm going to factor by grouping. So I'm going to group the first two. And I'm going to group the next two. And now I can factor it. So one factor is 3x subtract 2, and the other factor is x subtract 4. The denominator is easier. It's a simple trinomial. One step. What two numbers multiply to negative 4? And combine to negative 3. So that's negative 4 and positive 1. So step number 1 is not easy, but you have to do it. Can you factor it? That's step 1. Some of you draw a diamond and then go right to the parentheses, right? And you don't do the steps to get there. So recognize you have to do a substitution and factor by grouping, and then you can see the factors. All right, look at the denominator. Tell me what x cannot equal. 4 and negative 1. Now, is there a removable factor? So can you remove the removable factor? What is the 0 of what you removed? Good. What remains is your vertical asymptote. So when you look at your domain restriction, positive 4 creates a hole, and negative 1 creates a vertical asymptote. How do I find the y value of your hole? What do I do? So I'm going to plug in 4. So I have 3 times 4, take away 2, and then 4 plus 1. So 12 take away 2, 4 plus 1. What's the y value of your whole? Excellent. We're going to ignore the range. X-intercept. Look at the numerator. What's the 0 of what remains? Add 2 and divide by 3. Is that an odd or even asymptote? Has an odd exponent. So what does that mean? At 2/3 it's going to cross. How do I find the y-intercept? Is I put in 0 for x. Now, I'm going to do that way here at the beginning. If I put in 0 for x, 0 and 0, the only thing I'm left with is 8. And in the denominator, 0, 0, the only thing I'm left with is -4. So 8 divided by -4, what's my y-intercept? -2. Can you see how you can see it? Only from the constants, right? What's the constant over the constant gives you the y-intercept? Horizontal asymptote, and then we're going to graph. What's the power term on top? And what's the power term on the bottom? What would happen if you divided those? What are you left with? Done. Now we're ready to graph. So, can you start by putting down the intercepts? Yes.
Why is there no range?
There is a range. I'm just not going to calculate it. So I'm going to pretend that this isn't being asked right now. It is not important to me. So there is a range, but often for rational functions, you need calculus tools to know what the y values are because we have turning points and we're sketching it. So I'm concerned about the domain, but not concerned about the range. So I am just like, it doesn't exist to me. Be gone. Yes?
Is that in all the problems?
So when we have a simple rational, so a reciprocal, or it's simple to see what y cannot be, then yes, you can write down the range. Once we have turning points in our rational, then it becomes more challenging, right, to figure out what the range is, because we can only estimate a turning point without a graphing calculator. So I don't want us to be worried about the range unless it's a reciprocal, like something really simple of what y cannot be. I want to focus on the other parts. All right, so can you know where 2/3 is? You can only estimate that. Can you estimate where that is on your graph? Almost 1. -2. I got that. All right. I have an asymptote at -1. And we have a horizontal at y equals 3. One more thing. What did I not put on my graph yet? So at 4 and 2. All right, we're now ready to complete the graph. We're going to have a point to curve through in the top left, but we're not going to start with the left. Remember, if we have one vertical asymptote, how many pictures do we have? 2 curves. So do you see we have lots of information on the right? So what's the end behavior here? Is that the end behavior goes to the horizontal. So I want you to see this. That we have a hole to go through. So we have 3 things we need to connect. Make sure you hop over the hole. Make sure you hop over the hole when you connect it and see that the end behavior is the horizontal asymptote. What is the behavior at the vertical? There's only 2 options. Is it going to go down forever or up forever? So you can see what's going to happen there, yes?
Yes.
Do you see that our vertical asymptote, what is the multiplicity of the bottom? And because the multiplicity is odd, what do I know about the other side?
It's going up.
I already know the end behavior is what? So can you see it's going to go up forever and you know where the end is going? What don't I know that I'm going to find? A point, right? So what's a good x value I could plug in to find a point to curve through? So -1 is our vertical asymptote. So maybe -2? So what would happen if I plugged in -2? So 3 times -2, and -2 is -8, and -2 plus 1 is -1. So when you divide it, it's a positive answer. So -2 and 8. 1, 2, 3, 4, 5, 6, 7, 8. I could find more points if I wanted to, but I'm sketching it, right, in terms of the curve. One more time with your calculator. We'll type it in. And if you typed it in correctly, check to make sure the picture matches the question after you type it in. And again, my calculator is given that little vertical line there that's acting like where the asymptote is. And I don't know why it has it on there, I'll be honest. And there's probably a setting or it's having a hard time calculating the asymptote. But more importantly, does the graph match what we did? Why don't I see a hole there? If I wanted to see a hole there, where would I go to? Is the table. And if I go to the table, what do I see when x is 4? It is undefined. That's what's showing that at that x value it's undefined. That's what creates a hole. All right, turn the page. Now, this is where I have to let you go. So, I'm going to do a separate video for homework, but if I always do it for you, then you're not going to learn it. So, Mr. G Math over and out, lesson over.